Let's talk today now about combining selection and drift. And this is a little bit closer to the real world. We're looking at 2 of the 5 different fingers of evolution and how they can affect allele frequencies. So we're going to remember we are going to have selection present, and in this case it's going to be a recessive deleterious allele A1. We're going to have population size that's going to be 500. It's no longer going to be infinite. So the first thing we're going to know is the recessive deleterious alleles make this sort of shape that goes down, right? And we know that it's going to make that downward asymptotic curve. So why don't I put that on here first? You know, this is with population size being infinite. Let's put that on there, infinite population size. What we're really going to see, though, as a result of the 500, is something that looks more like, I'll put this in magenta on here. So it's going to vary a little bit with noise, but the noise is still going to drive it. It's still being driven hard by selection. And so we can see that it gets lost down here. Now, if we change that population size to something, basically, I should remind you what I've done is overlay random variation on top of a strong driving force of selection to drive this allele out of the population. But what if we take a population size of, say, 50? What happens then? And I think I'll change colors again, so we'll do an orange. What you can expect to see in that case is that you're going to have a much louder, probably still going downward, but it's going to be a lot noisier even still as a result of the genetic drift. And when we get down to population sizes of, let's say that this, you know what I'll do to make this all nice and accurate? I'll make this an orange population size 50. There you go. And I'll change this one over here to population size 500. That'll be in magenta. Okay, and then let's go ahead and put a third color on top of this one. We'll call it the blue line, and we'll make it a population of size 10. When you see a population of size 10, it'll start the same place, but you're going to get incredibly large shifts. And in this case, I'm going to let this one actually go to fixation. Now, it could go fixation, could go lost. You should repeat these multiple times in your allele A1 program. But the idea behind all this is that genetic drift is going to become stronger when populations get smaller, and can result in evolution, which is that change in frequency of alleles, that is not adaptive. And what that means is that alleles that are good alleles, like beneficial for fitness, can get lost. And those that are deleterious, like the one we're looking at here, can actually go to fixation, even in the face of reasonably strong selection. So you should be seeing these kinds of patterns in those examples in the allele A1.